This is a quick look at the setup for experiment number 9 on polarized light. There are a few main components. Again, we have a diode laser down at one end. Switch is located on the cord. Here's a fixed polarizer. Well, actually you can turn it by hand, but there's no labeling on it, and we'll use that to make sure that the light coming out of the laser is polarized in a direction of our own choosing. Next element shown here, which you'll use in a couple of parts, is an adjustable or variable polarizer. You can see the direction of polarization by looking at this tab on top, or when the 0 is lined up with the mark here, that indicates that it's transmitting light which is polarized vertically. And there's a table here, which nothing is on it right now, but there's also a glass plate that you can mount into the slot here, and you'll use that in the last part of the experiment for looking at polarized light when it's reflected off of a dielectric, in this case glass. And finally down here at the end is a photovoltaic cell, which is similar or the same as you used the previous week. And it's important to have on it, or should have on it, a diffuser, which is kind of a little bit, the inside here is recessed back. Make sure it's not sticking out. If it is, it means you've got to put it in there the wrong way. Just flip it over so the inside is recessed. And the idea then is that when the laser strikes that, it will produce a spot there that you can see and kind of diffuse the light, which is then picked up by the cell in back. And finally, you should also have a beam stop here at the end of your optical track, so that if the laser doesn't go into your photodetector, it will be stopped there rather than propagating around the lab. One more thing, we are also using the 4-channel digital oscilloscope, really only using one channel here, and you can see that channel number 1 now is plugged into the back of the photocell, just like it was, or should have been last week for some of your experiments. And I've got the scope set up so it's looking at channel 1, and I'm also keeping track of the voltage. This is DC RMS, full-scale measurement setup, again by hitting or by adjusting the measure buttons here on the side. You can set that up, and that will give you the average output from the photocell. So if I go over and block the beam with my hand, well, there's no beam right now, but I can block the room lights. You can see there's unblocked, there's blocked, that the photocell is responding and producing a change in the average response. Now, do the experiment, or at least for parts B and C, we're actually measuring something. You want to have the room lights dimmed. The experiment does work with the room lights on, but it provides a pretty big background. It'll make it harder actually to see the effects that you're looking for. So I'll show you a couple things here out in the light, but again, when you actually do the experiment, you want to have the lights dimmed or make sure that they're dimmed. So one thing to check on your photocell is that, let's turn on the laser here. You can see there the signal just jumped up, and if I look at the full-scale reading here, it's saying about 120 millivolts. If you see much more than that, that means probably that you don't have the diffuser on the end of the photocell here, and or the lights are on for the room. And it's best for operation of this photocell that it doesn't go over about 120 millivolts. If it does, you get some non-linearities. Certainly anything approaching half a volt, you really should have your TA take a look at it. All right, so laser is on now, and this is now set up in the configuration for part B, where you're going to be looking at Malice's law, which in fact involves looking at the intensity of light that's transmitted through a polarizer as a function of polarizer angle. And I've already adjusted the fixed polarizer so that it's transmitting light which is vertically polarized. It's relatively easy to do that. You just set the adjustable polarizer so it's at 0, and then you rotate the fixed polarizer until you see a maximum intensity coming through at the end. And that will then ensure that these two, the fixed and the adjustable polarizer, are pointing in the same direction. In part B, you'll basically then just measure the response, the full-scale reading from the scope, as a function of angle on the adjustable polarizer. In other words, fix the angle, say here's 10 degrees, check the voltage, 20, check the voltage. And you should see here, I'll just swing the polarizer angle. You'll see that, notice that if you're looking at the laser beam, that by the time you get to something around 90 degrees, it's very dim, and it changes steadily with that angle. So that's again just looking at checking that the variable polarizer is working the way it's supposed to. You should get an excellent agreement or good fit to the theory there. The second part of the experiment involves, or actually it's part C, involves measuring light, the polarization of light that's been reflected off of a dielectric block. This is a piece of glass. Here I just inserted it into the rotating table. And for this, you can see, here's, it's now spun around here, you can see that the laser light, I've got a polarizer here, vertical, that laser light reflects off. And if I look over here somewhere, you can see there's a couple of reflected spots actually from the glass block. And the reason there's two spots in this case is the light's coming in, it's striking the front of the glass, and some of it's reflecting off, that's one spot, and then some of the beam is continuing on to the back of the glass block. You might be able to see a couple of spots here where it reflects again and then comes back and kind of bounces around in the glass, comes back through the front surface and produces another spot. Now you'll see on your glass block some tape. I think we're going to get some blue tape for you. Here it's the glass block. Actually, I put it in wrong. I should take this out, rotate this around, and make it look like that. So what the tape is doing is, the purpose of the tape is to try to block the additional reflections. The only thing we don't like now is you might be able to just see where the incident beam is coming in. It's actually striking the block a little bit to the left here, and that spot on the tape is actually reflection from the back of the wafer, sorry, back of the glass. So if you've got the tape arranged properly, it'll block all the secondary reflections, and you'll just get one reflected beam into the photovoltaic cell. So the idea is that now you can measure the response or the amount of light, the intensity of light that's being reflected for a given polarization and for a given angle. So you'll sweep the angle by rotating the mirror, or I should say the glass block, until it's reflecting into the photocell. And this table, we give some instructions on the rotating stage how to keep track of the angle. It's not really set up right now. I don't have it adjusted so you can properly read the angle, but you'll see the instructions for that. So light's reflecting off at this angle, you measure intensity, record the angle, do another angle, etc. So it's relatively straightforward. At certain polarizations, though, there will be very, very little light that's reflected. So here if I switch to roughly horizontal polarization on this, you can see that now there's almost no light going into it's not visible with the camera, into the photodetector. It's a very small amount. And the special angle where that happens is called Brewster's angle. On the other hand, if I go back to vertically polarized light, you can see that it's very strong. So the reflected light depends on the polarization. And the one angle where you get no reflected light at this horizontal polarization is Brewster's angle, and that just depends on the index refraction of the glass. So that was a quick look at the setup. Hopefully it's a little bit clearer what actually you'll be working with. The lab manual, I should comment, was put together before actually we had final versions of all of the apparatus, but this is what it should look like for your setup.